Benzoin condensation reaction involves two benzaldehydes which undergo coupling reaction. Coupling here represents condensation, that means they combine to form a compound that is named as benzoin. Benzoin is also called as alpha hydroxy ketone. So the important thing what we have to remember is two benzaldehydes are going to combine, which is called as coupling or condensation, to give a product that is called as benzoin, which is going to be a ketone. At alpha position you're going to have an hydroxy group, that is OH. That is what you have to remember. This particular reaction will occur in the presence of KCN, potassium cyanide, or we can also use NaCN. If I am trying to represent this particular reaction, I'm going to write two benzaldehyde first. C double bond O H. This is a two benzaldehyde in the presence of KCN. It is also in the presence alcoholic KCN. Instead of alcohol, I can also write C2H5OH. And if it is diluted, you also write H2 when you are trying to represent the reaction. What we are going to get is this benzene ring is as it is. This particular C double bond O group will now be called as OH. This H will remain as H. Then they combine, this carbon will be only having double bond O group along with a benzene ring. So this compound is our benzoin. This is a functional group C double bond O, that is ketone. This is alpha carbon. At alpha carbon you have OH group, and this is also known or represented by the name alpha hydroxy ketone. Very simple reaction. What we have discussed before, we are just trying to represent it in a proper reaction. 2 moles of benzaldehyde in the presence of KCN and alcoholic solution gives benzoin. Benzoin is represented in this way, where at alpha position or alpha carbon you have OH group. That is the reason it is called as benzoin or alpha hydroxy ketone. The mechanism for this particular reaction is very simple. We need to remember here, before we go to mechanism, we don't have to explain every time that when I am taking KCN, KCN will get polarized to form K plus and Cn minus, that will have negative charge. So Cn minus can act as a nucleophile in this particular reaction. So the step 1 is Cn minus is cyanide ion will react with benzaldehyde. So the first thing is we are going to write 1 mole of benzaldehyde. In some notes, or for instance in my notes, instead of benzene ring I have written C6H5. We can also write instead of C6H5 benzene ring. It's up to you as per your convenience. So once it is written as I have Given the notes of that, I'll write on the same stuff here. There is C6H5, C double bond OH reacts with Cn minus. There is cyanide ion and it has negative charge. A negative charge cyanide ion will go and attack a positive charge species, and where are we going to get a positive charge species is due to the difference in electronegativity. Oxygen is going to get partially negative charge, carbon is going to get partially positive charge, and this will tempt cyanide ion to go and bind with carbon here, and this results in the formation of C6H5, CO with negative sign, hydrogen, and Cn here. The negative charge on Cn has 2 electrons that leads to this particular bond formation here. This is followed by transfer of this particular hydrogen towards negative charge on oxygen. So this hydrogen will be transferred in the form of proton. This results in the transfer of this bond towards carbon. So this will be represented as C6H5 as it is. Carbon and O will form a bond with hydrogen. So we will lose that negative charge. This negative charge has 2 electrons. That means this particular bond is formed out of that negative charge. So bonded with hydrogen so that the proton will be neutralized. Cn will be as it is, and due to this particular bond transferred here, carbon will have a negative charge. That means 2 electrons. Carbon having 3 bonds and negative charge is called as carb anion. Carbon having 3 bonds and positive charge was called as carbocation. Carbon having 3 bonds with a negative charge is called as carb anion. This is the first step where the cyanide ion reacts with your electrophilic carbon which has positive charge and followed by internal proton shift. It is also represented because it is having within the structure itself. So it is called as, this particular step is called as internal proton because it is in H plus form, proton shift or transfer. Once this is done, the second step begins with the carboanion form, that is C6H5 COH Cn with a negative charge on carbon combines with another mole of benzaldehyde. I'll write in the reverse way, that is carbon C double bond O H C6H5. Due to difference in electronegativity, this bond shifts here, partially negative charge, partially positive charge. So this negative charge on carbon can combine with the positive charge on carbon of the other benzaldehyde, and this negative charge, that means 2 electron, results in the formation of a bond between 2 carbon, this and this carbon. Thus we are going to see a condensation reaction where C6H5 is as it is, COH and Cn here. New bond is formed. This particular new bond is formed due to the negative charge on carbon. This carbon is this particular carbon we have written here. This O will have a negative charge, hydrogen as it is, and C6H5. Now just we are very close to a product, that is alpha hydroxyketone. How are we going to get is we have to remove the Cn from here. So in order to remove the Cn, there is going to be another internal proton shift. That means that I have to represent this OH as O-H, so that this hydrogen is shifting here in the form of a proton, and this results in the transfer of bond towards oxygen. This is a reversible reaction where we represent C6H5 as it is, with CO minus and Cn as it is, and here O minus will combine with H plus to form OH, H as it is, C6H5. So this particular O minus results in the formation of bond with H plus, so that they are neutralized. The final step is removal of cyanide ion. Removal of cyanide ion is due to shift of this negative charge towards this bond, so that Cn will be removed along with the bond here as Cn minus. So it is represented as Cn minus is removed. So what else is now our product is C6H5 as it is. You can do one thing here is, instead of write downwards, so Cn minus will be removed due to this bond being carried away by it. So C6H5, now CO minus will change to C double bond O, COH, H, C6H5. This is your functional group ketone, this is your alpha carbon, and this is your alpha hydroxy group, alpha hydroxy ketone, which is also called as benzoin. Condensation occurs in the presence of alcoholic KCN, where Cn minus acts as a nucleophile. It gets transferred here, followed by internal proton shift, results in the formation of carb anion. In the second step, this is the first step. In the second step, carb anion undergoes condensation with another benzaldehyde molecule to form an intermediate, where hydrogen here is transferred, that is once again internal proton shift or transfer. This results into formation of this intermediate, where O will be having negative charge, which will be transferred towards carbon, so that Cn minus will be removed. Then finally we get a product, that is alpha hydroxy ketone, which is also called as benzoin. This is very simple named reaction in this particular group. After this we are going to start with the final named reaction, that is Perkins reaction, followed by qualitative analysis of carbonyl compound and named reaction and structures and uses of few carbonyl compound which is mentioned. I recommend students to just go through the names of the compound which are actually given in your syllabus copy in the fourth chapter, where the names and uses, structures and uses of the compound is given. So please go through those names and try to look for their structures and uses, so that we can complete this chapter as soon as possible. Thank you.